I forgot that there was a 15-minute time limit on these videos. So I am back now. We have just titled our graph with a very descriptive title. So I can cross off number 7. And then the next point, number 8, is to plot our data with darkened spots. And for that, we go down to our data here. And these are the points that we are going to plot on our graph as dots. Again, we won't be doing bar charts or any other type. These are called scatter plots, and so they go with dots. So the way that I do this is that I start at 0 in minutes, so that's along the bottom here. I go right in here, and I go up to the 28 mark, and I put a dot. So for me, that is right here. That line in between 20 and 30 that corresponds to 28. Then I will move over 1 to here. This is my 1 spot. And I will go up to 30 and put a dot there. So these are pretty easy. Now you'll notice the next one, which has a time of 2 minutes, which will be right here. That's my 2 line. Has a time of 31, and I don't have, there's no line on my graph that corresponds with 31. This one is 30, and this one is 32. But what that means is that 31 is right in between them. So I just put a dot there. And then my next one, 3 minutes and 30 is 33, something very similar. So go ahead, pause this now. I'm going to pause the video as well and put in the rest of my dots while you put in yours, and then we'll join together again once all of our dots are placed. Okay, so I've got my 11 spots plotted. Hopefully you have more, but if you've got at least this many, that's okay. Now, we'll never connect the dots here. Instead, what I want you to do is grab your ruler, and notice how mine, at least, is pretty much a straight line. I'll hope yours is, without seeing it face to face. It's a little hard to guess, but it should be pretty linear. What we want to do is lay our ruler over this and draw a straight line sort of through the middle of these. Some of our dots might be a little above, and some of our dots might be a little below, and that's okay. I'm going to try my best with the tools that I've got here to draw a straight line with it. I'll do it in blue. This isn't great. Oops. This isn't great lining up different lines, so we'll see. But my line's going to be about here. Should work. Yeah, there we go. You'll notice that some of those points are a little above and some of them are a little below, and that's okay. So pause again. Come back when you have drawn this line through sort of the center of your data points. Right, now that we're back, we have done number 8, and actually we've done number 9 as well, where we've connected our data with a smooth best fit curve, and I used this part if our data is arranged basically in a line. And because it's in a line, we also get to do number 10. It says if your data is linear, we want to calculate the slope of the line with its units and record it on the graph. Happy day, we've got a linear graph here, so we can do all of that. Now, when we do this, I don't really want to use any of my data points themselves anymore. It might be that I'm using a point that matches up well with them, but I'm not really intentionally doing that. Instead, what I want to do is look for some places on my graph paper, like this one, where my line goes pretty much right through across on my graph paper. Now, I've got a fair number of them that are awfully close. I want to find one over on the right-hand side and one over on the left. And again, just like this one, I'm looking for a place where my line goes through across on the graph paper. That'll make those numbers easy to read. The other one I would choose for my data is down here, and it's not perfect, but it's close. Right there. The left one, which will be lower, labeled number 1. The right one, label number 2. Now we're going to find slope. You probably remember from previous year's math that slope can be found of a line by taking the rise over the run. Most students will remember that. Some will remember then how to apply it. I'm confident you've seen it before, so don't try and convince me otherwise. I've got a daughter who's a little younger than you. To find this in math, we would label slope as m. And the rise part, we're going to find the difference in the y components. We write that as y2, the y component of 0.2 minus y1, and we'll divide that by x2 minus x1. Now, what do I mean by those y's and x's? Well, go to 0.2, and if I go across, straight across to the y-axis, this will tell me y2. And so down here in my formula, I'm going to put the value. That is 50 degrees Celsius. Don't just write the number when we've got a measurement like this. Include the units. We know that we measured it in Celsius. And then that's going to be minus y1. So I go to 0.1 down on the bottom, and I take that over, and that is, so here's y1. That is 30 degrees in my graph. It'll be different in yours, and that's okay. For the x's, we do something similar, except we're going to go to the bottom. So x2, I take my 0.2 and I find the x coordinate by going all the way down to the bottom, and that is 11. So here's x2, 11 minutes. Go up just a little to show you that. 11 minutes. So x2 is 11 minutes. And x1, going straight down, is x1 is 1 minute. And we're going to do the math on this. In this class, we won't typically or almost ever leave things in fractions. So we're going to do all the math on this, which might require your calculator. Here I'm going to subtract the top. So 50 minus 30 is 20. And the units are still degrees Celsius. And on the bottom, I have 11 minus 1, which ends up being 10 minutes. Then our final step is we divide those numbers out. So we take 20 divided by 10, which for me is 2. And then we keep the units just like we've written, which is degrees C per minute. We'd read that over minutes. Right? And here is our slope. This is how to finish off all of these points. That was number 10. Produce a good graph and learn something about it. This means that on average, our candle, in my candle, with the data I made up, was increasing the water temperature by 2 degrees every minute. I suspect you will have a little bit different measurement depending on how much water you had, how high you raised it, and all of that. But I hope to see some similar calculations when I come back to class, hopefully, like I say, very soon. Okay. Hope to see you real soon. Bye-bye.